Perfect. Hi, everyone. If you're on the stream waiting, we're going to give it another approximately 5 minutes before we start so that people can trickle in.
Hello there.
Hello.
We made it. It's 2022.
Thank God. Welcome, everyone. Great to see you guys. I hope you all had a great New Year, or at least a great holiday, a tiny bit of a break. For those of you who didn't, I'm very sorry on behalf of all InfoSec and all software security. Welcome. It's great. We are partnering again this month with the OWASP Ottawa crew. I'm from the Toronto crew. If you've never seen me before, so here's if you have any housekeeping notes that you wanted to talk about, Garth. Otherwise, I'm just going to get straight into a quick overview of the agenda, and
Bring
then
it.
we can go into it.
Let's go.
So well, Garth and I are going to do a really quick intro to update you all on what's happening with the OWASP Foundation, and then we'll hand it over to Alex for his talk um, on how to reverse engineer, or sorry, yeah, how to reverse engineer binaries with one stupid trick. And then we'll take a brief intermission for about 10 minutes so that we can all get up, stretch, uh, take a bio break, get some water, things like that. And then Suchakra is going to take us through analyzing source code vulnerabilities for software issues, and it's a workshop. So if you want to follow along with his demo, then please follow the instructions that are posted into the respective chats around downloading VLC and downloading Jorn, I think it is. And then there's also, as a last kind of housekeeping note, a survey that ShiftLeft has put out, and they're offering a Amazon gift card for anybody who does fill it out. So that's totally optional. We try not to push too much of anything on people who are on the stream, but it's there in case you'd like to do it.
Nobody orders online during a pandemic.
No, of course not. All right, let's go. So welcome to the event. Let me just switch to kind of the next slide. This is our respective crews. You want to introduce very quickly your group, Garth?
OWASP Ottawa I'm a co-lead. My name's Garth. I'm a co-lead with Sharif, and it wouldn't be possible without the help from Rick, Dave, and Scott and Adam, who are not pictured here. We make a great team. They're fun people to work with, and we have a lot of laughs each month as we try to put a meetup together.
Yeah, I would say echo all of those things about the Toronto team. Today it's just me, so I'm Opheliar Chan. Everyone calls me Ophi. That's my picture on the very, very, very far right. But of course, the team is made up of also Adam and Jack, who you see often emceeing our OWASP Toronto calls, Yukfe, who is the magic behind the group, and then Ignatius and Matt, who have been doing lightning talks for us and are also part of the important part of our volunteer crew. So that's us. Let me just switch
Next
to the
slide.
next one. Yeah. So as you all know, OWASP.org is where the majority of our online presence as OWASP Foundation is. There's both the website and all the materials that are on it. Annually, we have, at last count, it was something like 7 or 8 million people a year who go, and I'm sure that that number has increased since, especially since we're all online now. Worldwide, we now have about 100K members and about 247 chapters or groups that work on either projects or hold meetups like this one. We're in 75 countries now and expanding, and looking obviously always for new outreach partners and for new chapters to be started.
Our devious plan is working.
Hey, well, it's not working as fast or as good as we would like, I would say.
So there are
Um,
chapters in
there
Canada.
are chapters. Yeah.
And as you know, you're listening to either OWASP Ottawa or OWASP Toronto. There are chapters in Waterloo, Vancouver, Victoria, and Quebec City. There are, and flame me quickly if I'm wrong here, but Based on our more recent investigation, there are some chapters that were chapters but aren't very active. So this is an opportunity, if you're either in any of those areas, to restart the chapter with benefits.
Hmm. And we've been talking to a number of chapters in the Canadian region and in other regions who are trying to start up or restart. So if you're looking for tips, tricks, connections, what have you, happy to assist there if you decide that you want to take on the challenge of doing some fun things with your community. Okay. We just finished, OWASP just had its 20th anniversary last year, right? And so the keynotes for those are available to everyone on the OWASP YouTube now, and also the full conference track for all of the speakers, not just the keynotes, are available to OWASP members. So if you are a member, now's a good time to start looking.
Membership has its benefits.
It does have its benefits. From a global AppSec virtual standpoint, sorry, this should be say 2021, but I fumbled it. All 57 tracks of
It
the
feels like 2020.
I know it feels like March, what, the 600th and something day of March 2020. Um, but if if you didn't end up going to the AppSec Virtual 2021, sorry, all of 57 tracks are available on the OWASP Foundation YouTube channel as well. And there are some really interesting talks there around like WebSocket security, around, of course, cloud security, some threat modeling, and then, ever popular things around hacking Ethereum and blockchain, things like that. So if you haven't checked it out, it's worthwhile to go through the OWASP Foundation YouTube channel and just have a glance at all the different talks that are available since it's free. Uh, what
Membership.
I'm going to talk about membership.
Yeah, let's talk about membership. So you might get the idea that membership has its benefits, but to do all the awesomeness that OWASP does, that does cost some money. And so one of the ways that OWASP funds some of these is through memberships. And as you can see at the bottom of the screen, that this is a Canadian-based cost. There are different costs if your region has a different economic situation. So it is prorated based on the region. So these membership costs help fund projects, events, and the OWASP mission.
Mm-hmm. It used to be that, you didn't get that much more from membership than having the warm fuzzies that you would contribute to the mission and also an OWASP email address. But in the last year,
Yeah.
the membership benefits have gone up significantly. So I like Garth can go through them, but I can attest, like, it's been the cheapest $50 I've ever paid to get the quality of training that is available now.
So the other thing is that there is a method by which you can get a free membership, and that you can ask for that free membership by being either a chapter leader or being involved in some of the projects. And once you're involved in one of those projects, then you can request to get a free membership. But with that membership, you get benefits, and there's a list here that mostly goes around training discounts, access to an email address, so you get an owasp.org email address, but then you get access to the full Google suite of goodness in terms of all the capabilities, like doing the slide deck. You also get involved in the direction of the organization by voting on your board elections. So you get the people with the platform and to put the direction of the organization where you want it to go. We've mentioned already the training, the discount on the training, the free training, access to the free training, as well as discounts on international events. And, maybe one day we'll get to see humans in person. But probably nice. One of the more direct one that I want to speak to is that being involved in OWASP, either as a chapter leader, a chapter volunteer, or involved in one of its many projects, that gets you access to a network, and that will get noticed. And so the fact that my CV has the fact that I'm involved in OWASP, I'm involved in a chapter, I'm doing these things, that gets noticed. And that is a in the marketing phrase, a competitive differentiator. So that is a definite plus in that regard. I think I've beaten this slide to death, so let's move on.
Okay. But to that, I wanted to add, like, I got my current job because of OWASP. So if you ever are looking to become a senior manager or something like that in a large consulting company, a lot of the job offers that I've gotten incoming have been because, hey, I saw you on an OWASP Toronto thing. You want to come work for me?
Definitely
So
is.
projects, we
We've
still,
got some, right?
pardon?
We've got some, right?
We've got some, yes, but we've still got around 180, not 190 projects, including the 20 flagship projects that do get funded. So if you're not familiar with like how projects are split, they're split into three different kinds. So that we have tools projects, documentation projects, and coding projects, and they're usually aimed at three different kinds of people. So builders of applications, so that's like developers mainly, breakers of applications, so pen testers, red teamers, that kind of thing, and then defenders of applications, so security ops, governance and compliance practitioners, and that category of people. And then the classifications that you'll see on this slide are the flagship projects, the lab projects, and the incubator projects. And the flagship projects are the ones that have demonstrated strategic value. And so they actually get funding from the organization, from your memberships, from corporate sponsors, from things like that to have a roadmap and develop the projects further. The lab projects are ones that have been reviewed by the foundation and are delivering value to the community, but don't yet have official set annual funding. And then the incubator projects are the ones that are like experimental. People are trying them out. People are developing the ideas and they're fleshing it out, and then still working on it, things like that. So these are the projects. Not that many of them have changed this year. You can kind of see the same ones as in previous years, but the new one that's interesting is the top 10 low code, no code security risks, OWASP top 10 category. So every once in a while, somebody comes up with a new top 10 list, and a lot of research and development goes on behind the scenes for that one. So we'll talk about it in a sec. The
Low code,
lab,
no code?
low code, no code. So let
Sounds
me,
like smokeless ashtray.
oh gosh. No, no, no. So, what's happening in the low code, no code? It's development platforms that are more like GUI based, providing development environments to create software or applications or like chatbots or something like that using more user-friendly methods instead of like hand-coded computer programming. So that one Excel spreadsheet that does all your data viz in your organization, the one chatbot, the Microsoft, what is that thing called? Microsoft's new Power Automate, all of your uh, out of the box or assisted like Slack actions or those kinds of things are all considered to be low code, no code because you fill out a form or something like that and you assemble the pieces, but you don't actually do hand coding in the background in a programming language. You do it through assistance of both a graphical user interface and or some other kind of like assembly mechanism. So in that area, there are a bunch of vendors who are coming out with these platforms and to do what they're calling low code, no code. And so this project is to provide a top 10 for those vendors who are doing that and for people who are assessing a low code, no code solution internally to their company to see what some of the common issues are. And these guys are looking for volunteers, data contributors, translators. They're the newest project that will probably have very wide impact to all of us. Again, if you are a part of a company and you know some parts of it are being run by Excel and like this humongous spreadsheet, that is low code, no code. So the leaders are Ori, Michael, and Ben. They're on OWASP Slack and always looking for contributors, data contributors, and other people. So now's a good time to volunteer if you want to shape the future of this area of the industry and also get your name on something that's a top 10 that's going to go into every standard under the sun.
Releases. There have been a number of releases over the past month. Threat Dragon, which I believe OWASP Toronto talked about a couple of months ago, has a new release in December, as well as something called Security Code Box, which had an intriguing title, so I had to go check it out in terms of automating security analysis using Kubernetes. Anyways, OWASP Zap, you may have heard of this. An awesome tool had a 2.11.1 release in December. I can hear Rick in the background going, woohoo! And as well as the mobile security testing guide and the mobile application security
Verification
verification
standard.
standard. Yes, say that 3 times fast. Juice Shop, this is an awesome pen test or training environment for a modern web app, vulnerable known web app. Has a new release as well as the Mod Security Core rule set, which announced the Coraza. It sounds like a flamenco song. Coraza Seclang engine that came out in December as well. So lots of movement, lots of busyness.
Mm-hmm. These are just some of the projects, not all of them. I don't think we can track all of them unless we spend too
Right.
much time on it. All right.
Do you know anybody who's been involved in Log4j recently? Have you been to a Log4j party? Have you been using a laptop at Christmas as your children open their presents, working on searching for Log4j components? Would you like to avoid that entire circus again and again? Then I think you probably want to check out a couple of these tools like Cyclone DX and Dependency Track. And the reason for this is that this is the issue known as continuous asset management, and these two projects might help you quite a bit. Cyclone DX is a lightweight software bill of materials standard, which plugs directly into Dependency Track, which is got a funky front end that allows you to track the entire dependencies of your project, and it automatically updates. So when so for example, you got mayonnaise in your fridge, you have no idea when it goes bad until it's too late. With Dependency Track, it will tell you when your mayonnaise or your Log4j goes bad. Shout out.
We just had a talk on software composition analysis, so it's basically the open source version of that.
Exactly. I was scared you had a talk on mayonnaise. Anyway, so you have a shout out to the open, and I have to read the microfilm here because I always get it wrong.
Open Source Security Foundation.
Open Source Security Foundation. And OWASP is involved in this as well as an advisory member on their planning committee. So big shout out to them because they'll play a big role in our open source world. Just as I'm just reminding myself that our first presenter gave an OWASP talk some time ago, and he was sort of like warning us about all these vulnerable packages in PyPy and other package management systems. So a big shout out to Alex, the ghost of talks past.
Mm-hmm.
Next slide.
We'll see him soon. All right. So do you want to cover this one or should I?
It's your turn.
Okay. So we're working collectively in the Canada region on a Secure Code Warriors tourney. So if you're not familiar with Secure Code Warriors, it's a secure coding training platform. They have a couple of different modes, and one of them is a tournament mode. So it's like secret spy stuff, and you go in and try to figure out, which part of the code base has a problem, what the fix might look like using diffs. It's actually kind of fun. I've done that at a couple of conferences in the past, and so we're trying to put together one. And well, we, as in actually the OWASP Vancouver office, I think, the OWASP Vancouver group, and they've invited us along. So coordinating on that, we'll get back to you on when that date is. But the other exciting thing is that there's a OWASP career fair. So they're doing the first one on February 22nd. It's online. You can sign up for it. If you're looking for work, obviously it's free. All welcome. On February 22nd from 9 a.m. to 5 p.m. And if you're a employer looking to tap into the OWASP group and its membership, then now's a good time to go book your spot. On March 8th, there's ZapCon. So OWASP Zap has a conference, and you can go sign up and check out what's going on with Zap. All right. Next.
Ottawa, yes. So watch this space. We will be talking about having a regular study group. It will typically consist of selecting some subject area, a book within that subject area, and a weekly get together where we talk about a chapter in that book. Maybe somebody will present, somebody will talk, we'll at least talk about that chapter. And the goal here is to learn whatever that subject area is. So look for surveys on subject areas. And if you want to shout out to what's that thing you want to learn that's most important to you, then give us a shout. And then in February, we've booked the Jim Manico to talk about something other than the OWASP Top 10. So his second subject of interest is request forgery, both CSRF and SSRF, and maybe there'll be another RF by the time he does the talk. So look for that in February when you're not down by the beach or by the pool. If you want to get in touch with Ottawa, yes, I know it's the town that fun forgot, but if you want to talk to Ottawa, we've got a meetup page. So there's the link there. We have our own Slack, and the only reason we have our own Slack, it has nothing to do with security clearances or that we want to consider ourselves separate and special. We just set it up first and we just kept it going. So we have our own Slack. And so there's the self-invite link. YouTube, you're watching this, so you're probably already aware of that. And we're on Twitter because, we like to be on all the anti-social medias, as well as the chapter website under the OWASP banner. Next.
Yeah. All right. So we've got nothing quite so exciting as a study group, but our next talk is next month, Insider's Guide to Mobile AppSec. So somebody's coming, Brian Reed, the Chief Mobility Officer of SnapSecure, is coming to talk about application security relative to the ASVS. So please come to the talk, or at least enjoy the video afterwards. You all probably know how to get in contact with us. We're the same in a lot of senses in social media presence as the OWASP Ottawa crew, although we don't have our own separate Slack. We borrow the OWASP Foundation Slack. We have a channel there, so please come talk to us anytime. Okay, so that's, I think, it from this.
Is that it?
So we're now gonna turn it over to Alex DeVries. If you're not familiar with him because you are a OWASP Toronto attendee for the most part, Alex is one of the OWASP Ottawa presenter alumni. His past talks have drawn some of the largest OWASP Ottawa attendance, memorably his talk on, I think it was compilers and bad assembly, and then on software supply chain risks. Like he was talking about lousy repository security. So that would be your NPM, your PyPy, things like that. And if you were interested in those topics, you can check out his recordings in the OWASP Ottawa YouTube, which has a long-standing presence there, as opposed to the Toronto, where we started a little bit post-pandemic and are hoping to carry it forward. So
I remember Alex's presentations live in person with other humans in those halcyon days when we had pizza.
I'm going to hand it over to Alex. Give me a second to get him on. Oh, sorry. Add him to this stream, and then also his.
And what terrible pizza it was, Garth, but at least it was free. So thanks to Ophi and to Garth and everybody else on both the Toronto and the Ottawa OWASP sides. I know that it's quite a bit of work to put these things together. And there's some caretakers that are always, pull things along, like Scott with the music earlier, and stuff like that takes a lot of work. And so it's important to recognize those people too. So I'm Alex, presented a few times. My day job is as a security architect and security champion at Ericsson, where I work on cloud security, web app security. But this talk doesn't have anything to do with that. It goes back to some of the work that some of my own interests, which is around reversing binaries. So I thought it might be good for us to get into what this is all about. Okay, so why would somebody want to reverse engineer software? So, you know, some of it is you might just be curious as to how something works. You might have there might be secrets in there that you want to steal or somehow use them. Sometimes you want to change behavior of some software that's running. You know, now who would want to do this? Well, first of all, we need to expect that you know, the malicious actors are going to be doing reverse engineering, so it's good to know what they are doing. But sometimes it can also be good for things like penetration testing or doing security audits. The kinds of tools that you might want to use are network sniffers, so you can get some software running. Then, you know, tap the network interfaces to see what traffic is going across. You can also use things like strace or system call handlers and sort of see what the application is running. You can also use inspect the editor or use an editor to inspect the executable to see what's in there. And then you can do some pattern searching, look for certain things, and decompilation. I'll get a bit into decompilation here. Okay, here's the thing that I have, you know, perhaps I was mistaken about in the beginning days of my attending OWASP events, and that's OWASP really is focused on web applications, but that isn't entirely true. And here we're going to wander away quite a bit from web applications. But I want to sort of categorize applications into programs that run in 3 different ways. I said, first of all, there's interpreters, right? So an interpreter takes the program, which is probably a text file, and you know, interprets what's in it and executes things. And often it doesn't actually do any syntax checking until, you know, it hits an error. Okay, so examples of that would be PowerShell or Bash, right? Those would be examples of interpreters. The next one is things that use a virtual machine of some sort. So the Java uses a JVM, and Python runs on a virtual machine. I'm not talking about a whole OS virtual machine, I'm just talking about something that'll run a language, a program. And then there's binary executables. And binary executables often are written in C or C++, maybe Rust. There's going to be other languages that compile down into binaries also. There are going to be quite a few esoteric ones too that compile down. Fortran would be an example. So now, not everybody will know how binaries are created. So I just thought I would give a brief overview of this. So the first thing is there's a developer and they write source code, right? And this is human readable, right? You can put comments in it. They can use indentation. They can use function names and things like that. Things that will, you know, can be interpreted by a human. Okay, but then there's a step where they compile the code, and the compiled code that, you know, comes out of this is called assembly, and it's a text file, and a human with knowledge of the CPU can read it, right? So, you know, in this example, you can see that it's making it's moving some memory segments around or some memory around. It's calling a function, right? This is somewhat legible by a human. And then the next thing you have is you have the binary, and the binary, you know, it's assembled. The assembly is assembled into a binary, and that's what the CPU runs, and that's just like a stream of bytes. So when I install Microsoft Word or something, I'm just getting the stream of bytes, right? I don't have access to the assembly or the source code. Okay, so how do you go back? So if all you have is that binary, how do you get how do you get back to the source code so you have more information? All right. In going through the steps, you actually lose information through these stages. And the kinds of things that you can lose that are quite relevant in understanding how the program works is line numbers and file names are really useful. Names of symbols, things like procedures or functions or variables, you lose those. You can lose comments. So, someone is saying things like, I think there's a bug here, or, this is the flag to set for entering debug mode, things like that. Comments are really quite useful. Also, data structure, so how stuff is sort of mapped into memory, particularly with class structures. It can hide whether or not there's debugging features. Also, like, you can just, some programs are compiled with, debug equals off. Also, you can actually obfuscate binaries that really, during the compilation, so really the binary is very difficult to sort of untangle. However, in truth, many, many vendors do not remove these items. Many of them remove some of these items, but in other cases, they do things like leave all the symbol names in. Very few binaries are actually obfuscated at all. You'll actually find quite a few binaries that have things left in. Okay, I'm going to show off Hydra. Hydra is from the NSA, and it's an open source software reverse engineering tool. It's written in Java. It runs on every platform I've run it on. And it's a tool that'll help assist a human in analyzing the binary. Now, it will only be able to do, some of the information is lost, so a human has to sort of fill that information in, but Hydra can really help you with that. So the kinds of things I'm just going to show in this live demo is I'll import a binary into Hydra. I'll scan for symbols. Try to show you a few things about how to look at control flow, fix up some names, and then we'll patch the binary and show that it's changed. Now, I'm brave by doing a live demo remotely like this. So, if everybody could please just say a prayer to whatever God you worship, if you worship one at all. So I'm going to start by showing you a program that I have. I have a program that's called Treasure. And Treasure, I don't really know what it does. It's asking me for a password. So, I'll enter some stuff and it says it's wrong. And then, it'll ask me again. I'll still say it's wrong. And I'm like, oh, what is the password? How do I fix that? Okay, there's lots of ways to do this. I'm going to show it to you with Hydra. And the deal with it is that there are a lot of ways you can solve. There are a lot of things in Hydra that you can do. And I'm going to try and show you everything that I possibly can in to 12 minutes or something. Okay, so I've started up Hydra, and I am going to, first of all, open it a little bit differently. Let me just do this. I have my notes. Okay, so I'm going to import the file, and I'm just importing the straight, executable that I was running. Okay, so the first thing it does is it says, oh, okay, hey, I identified this as a Mac door file. It's compiled for x86. Enter the program name, and there's a weird bug here that I'm going to use. I'm just going to skip over. And it's going to say, okay, well, I found it. Should I analyze it? So I'll say, show me all the analyzers you have. And so I won't spend a lot of time on this, but I'll just highlight some. So in this analysis thing, right, what it's trying to do is go into the binary and extract information out of it. Okay. ASCII strings, it's going to go look for ASCII that's embedded in there. There's decompilation, various decompilations, which is converting assembly back into something that looks like C. Function ID, so it actually look in the binary and find, based on signatures, see if it's actually source code that it has found in other binaries. Let's see, the stack. It analyzes the stack. Won't go too much into the stack. If you don't remember what a stack is or don't care, you'll be fine in the rest of the demo. I'll touch on it briefly. So it has many of these analyzers, and I've highlighted some of them, but there's more, and you can plug it in. There's an error here. Ignore that. Okay, so here's what I got. So that I just have it open to the symbol table, and the symbol table is, certain functions and variables that are found throughout the binary. I'll just talk about I'll highlight the ones that are important. So the first one is main, and main is it's the beginning of it's the entry point, right? That's where things start. And you can see that what it did was it took the binary and decompiled it and created this C-like function. Okay, and then there's something called authenticate too. I don't really know what that is. We'll see. Validate password. There's that. It gets a bit more complicated. And print treasure. I don't really know what that is, but we'll find out. Okay, so a way to do this to start, just to get a feel for the call flow, is we'll use the function call graph. And the function call graph, you can see here, oops, you can see it's got the entry point, which is the same thing as main. It calls a function called print treasure. And print treasure, I can zoom in, it calls printf. The entry also calls something called authenticate, and authenticate calls something called validate password, which then has a few system calls. Okay, and then authenticate also calls printf and sleep. Okay, so let's go back and just have a quick look at the entry. Okay, so this is oops, I'll do it this way. Yeah, there. Okay, so that's really main. All right, and you can see that it's going to call a function called authenticate, and it says, hey, if it's auth okay, if it's not auth okay, then say sorry, can't authenticate, and then exit, right, dump. And if it passes all this properly, then it goes and calls print treasure. Sounds good. Okay. The first thing is it's a bit weird with like avar, because obviously the compiler couldn't guess on what the compiler what the symbol name was. So I'm just gonna rename it. I'm gonna do this here by saying rename variable. I'm gonna call it is authenticated. And you can see it changes it in line. That's cool. Now let's go see and look at authenticate here. I just double clicked on it. So it's got this this other Boolean here, and it's got this loop. And it, if it fails, then it sleeps for 3 seconds and asks you to enter it again. Okay, so let's change that. All right, let's go look at validate password. Okay, it's a bit more complicated, but we'll mark this up. So now this is a good time for me to actually look at the code listing. So the listing here is the assembly code that it extracted from the binary. So you can see it's a function called validate password. And you can see that it derived the stack. And the stack is, where in memory relative to the stack pointer are the different variables. There's actually no variables passed here, but there's some that are allocated. And you can see this section here, it defines what they all are. Okay, one of the things, and I'll skip over this part quickly, is the stack canary. So it always inserts a command, some functions related to a stack, but stack protection. But I'll try and be quick about that. So the next thing you can see here is it's print out string, and it asks you for your password. Now, when you ask the next call fgetS, that's get a string from standard in. So person's typing in their password. So clearly what it does is it's putting it into a buffer. So astack27, right, which is set as a character array, so 11 characters. So I'm just going to rename that as buffer to make it a bit clearer. Okay, then next thing it's doing here is it's getting the length of the string. I'll rename that, and you can see buffer at len, right, at the len position is setting to 0. So what it's doing is when you're typing your string or your password and you hit enter, it's just chopping out the last character. So the next one here, the string compare. So it's looking at what's in the buffer. It's comparing it to foobar. So hey, maybe foobar is our password. Let's go ahead and give it a try. Come back here. I'll go run treasure. Foobar. Boom. Okay, so I was able to do that by extracting a string. There are other ways to have found that string. Another one would be you can just go to the strings browser, define strings, view, and in there, somewhere in here, you'll end up with the different strings, and you'll end up with foobar, and you look at foobar and say, hey, why don't I just try that? And you try it, and you get in. Okay. Now, the next part is a little bit more complex, but I will show you. So let's say though that instead of it asking me for a password, I just want to like skip the whole thing altogether. So I just want to change the control flow. So let's do this. It's called validate password, and validate password, you can see it returns either 0 or 1. There's a bit of logic there, and it's a little bit obfuscated, not intentionally, but it's a little awkward. But you know what? We can tell by looking at how validate password is called, right? We can say when it is called, it checks to see if it's 0 or 1. So you know what? Let's just get it to always return 0, right? So it's always validated, and it never asks for a password. Okay. Here's how I would do that. So you can see in the listing, the assembler itself, you can see that the first instruction that it calls here, the push, and they're just doing some stack stuff. Don't need to worry too much about it. And after that, it proceeds and shuffles some stuff around before like it checks the stack and goes through. Okay, you can see the first line under validate password, it says that it's setting EAL, the return value out of the function, is saved in the register called EAL or AL. So if I want to, what I can do is I can actually just patch this first instruction, right? And so if I made the instruction of move, and I want to move into AL 0. Okay, so that's taking the AL. It's just moving 0 into AL, and whoops. Oh, okay, sorry, I'll do this one more time. The thing about these tools is they're incredibly powerful, and also like the user interface is just terrible. Okay, there's the instruction. Don't ask me how I know that. And the next thing I'm going to do is, so I'm going to set the return value, and then I'm just going to return out of there and just ignore the rest of the assembly. So I am going to patch that instruction, and that instruction is just going to be return. Whoops, that has to be capitals because this is it. Okay, so that's it. So now you can see if I go up top and see what it actually changed the function to, you can see it just nulled it out, right? So what I'm going to do then is I'm going to take the patched one and I'm going to export the program, because now it's patched up the binary. I can do export program. Ask me where to put it. I'll put it wherever. Excuse my screen sharing problems. Okay, so I've just saved it. Now, I have a new one. Treasure a.bin that I created, and I have return, and skips the authentication altogether and just goes right to the meat of the program. So I think what I've shown here is showed importing the binary into Hydra. scanning for symbols and getting a feel for what's there and sort of browsing the control flow. So we fixed up some names. I didn't actually fix up some types. Not too complicated for this presentation. And showed me patching the binary to change the behavior. If you have any questions, just put them in the chat window. I'll probably catch up here in a few minutes. All right. Other things, just to wrap some of this up. So lots of stuff I didn't show you, couldn't show you. Handling of data structures. So things like structs, unions, it has some ability to detect some of those. Also bit masks. But a lot of it is really sort of human-assisted tools, lets you sort of structure, relabel things and change memory allocations and alignments. C++ classes, so it has the demangler, so it can change the names into in the binary to things that are somewhat human readable. It sort of works. Also, there's fun plugins that'll look for like inline JPEGs or images, and also certificates that are embedded, and also can look for some patterns related to encryption algorithms. Didn't show you the interactive debugger. Can really help a lot by sort of stepping you through it and letting you interact with it. Also detecting libraries that have been statically linked in. You can also export it to C, which has never really worked for me completely. But it really is a fantastic tool. So just to wrap this up, so you should have a look at it. The competition. I used Hopper for quite a while, which was $50 or something. Was pretty good to me. It's Mac only, somewhat limited. I would say excellent value for the money at the time. IDA Pro. The thing about Hexarray's IDA Pro is that it really has been the leading tool in decompilation. Really is an excellent tool. I'm told, but I have never used it because it is far beyond my budget, and unlike some mentions in the comments, I'm not keen on cracking or stealing software. So I have never used IDA Pro, but the thing about Hydra is it is open source. It is getting a lot of attention. I mean, I think a lot of it is the NSA just had a lot of software that they were maintaining on their own for reverse engineering tools, and at some point, there's not a lot of value in it, and it's in keeping it proprietary. So it was cheaper and easier for them just to form a community around it. There's lots of plugins that you can create, or other, there's a marketplace of plugins that can be quite useful. I think that's all I have for today. Hopefully that was a useful introduction to Hydra and a bit about reverse engineering.
Thank you very much. You actually preemptively answered the question with your review about IDA Pro in terms of or a review of some of the other
Actually, Garth, I saw it in the chat window and quickly edited my slide to include that table.
You are so awesome. So you said this was released by the NSA and it was open source, which indicates to me that it was a planned thing. But I also know that some other things they had escaped, and I was wondering if it was one of the escapees that became open source afterwards.
Oh, I don't think so.
Okay.
The fact that he's entertaining your question seriously is kudos to him for being able to handle just far left questions.
I thought there might be an interesting backstory there. Any recommendations for learning more about using Hydra?
Yeah, let's see. Oh, maybe I should have mentioned this, but perhaps one of the greatest assets of Hydra is it actually has excellent help. The technical documentation is great. I don't say this very often. I mean, a lot of us use these sort of tools and we just sort of expect that they will work. And sometimes they do, but Hydra tends to be a little bit rough around the edges sometimes. And no, I was thinking of like the documentation is sort of the last thing that I want to look at. Anyway, it's really good, and I would say the awkwardness of the user interface, et cetera, sort of goes away if you actually bother reading the documentation. So, I mean, maybe this is true in the world in general, where tech pubs is getting a bit more attention, is a little bit better. But Hydra's docs are actually really good. And part of the problem is it's changing so quickly that I'm not sure you could really, you couldn't have a book about it.
Well, actually, Frederick actually gives in the comments, recommends the No Starch book on Hydra.
Well, I should have a look at that. Yeah. For reverse engineering, actually the Reddit software reverse engineering pages are pretty good. Otherwise, it's kind of scattered. It can be a very like some of the tools can be pretty easy or pretty easy to understand when you have a basic understanding of how software is built. But anyway, yeah, a lot of it is just play around with it.
Awesome. Thanks again. This will be in our YouTube video list, so we can always refer back to it. Ophi, you want to introduce the next presenter or just give us a teaser trailer on the next presenter before we go to intermission?
Yeah, absolutely. There's another question here by
Yarrow
as well. So maybe we can do that one first.
Oh, yes. Hey, Yarrow. I know Yarrow. So can Hydra handle obfuscated code? Of course, what I showed you just now was a really simplified binary, right? I mean, there's nothing. I wrote the code. It's trivial. How does it do on more complicated things? So there's a couple of open source obfuscators out there, and it does very badly on them. How is it done? How does it do on, let's say, regular binaries? Pretty well. Let's just say there are some very common games that I've found that have passwords encoded, and you can understand control flow and things like that. I would say it's pretty easy to deceive Hydra if you wanted to. Most software vendors aren't looking to do that, though. Obfuscated code can also sometimes be slower, depending on how it's written, how it's obfuscated. Do you mind if I just read off some of the questions here?
Yeah, go for it.
Let's see what else. Deval says, is it possible to bypass where application relying on auth server using these type of traditional methods? Where the application? Yeah, sure. So some programs will go and do a remote authentication and come back with some sort of token or something, and you could just interrupt that and circumvent that, or sometimes even just recording what it is. So an interesting thing would be a reverse engineering tool that involves interactive debugger as well as something that sniffs the wire. That's sometimes pretty useful. So that way you get information from two different sides. Let's see. I don't see any other questions here.
Yeah, I think we're good for now.
Thank you for your support in contacting your demo gods. That was much better than I thought it would. I'm going to go grab a beer.
All right.
I'm there.
Thank you. So before we go to intermission for about 10 minutes, let's introduce Suchakra. So let me just switch around. Right. So we'll come back to Suchakra's talk on analyzing source code vulnerabilities, a how-to workshop. Again, if you are part of the live stream, you can follow along with his demonstration if you download the components, and we'll put those back up in a minute during the intermission into the chat. In the meantime, there's also a ShiftLeft post-event survey. They're trying to ask about, how you do AppSec programs at your company, and so you'll find it in the description. I'll repost that one again as well. Of course, that's optional. ShiftLeft is offering a $40 Amazon gift card to the people who fill it out, but that also means they'll get your email address. So FYI always optional. So, all right, I'll stop there. Uh, and then hopefully you will come back and join us and Suchakra in about 10 minutes. All right, let's go to intermission. Thank you. Alrighty. Hi, all. Welcome back. So, we have with us Suchakra, and I'm not going to introduce myself because I'm sure you have your own intro.
It's the name is written down there on the screen.
Yeah. Hey everyone. So I'm Suchakra. So should I go ahead and introduce myself right now,
Well,
or run through the slides?
yeah, I was just going to welcome people back for the Analyzing Source Code Vulnerabilities talk, and then me and Garth are going to both go off screen, and the floor is all yours.
Okay,
Great,
perfect.
thanks.
Okay, so yes, so this is the second talk for the evening, and it kind of like builds upon the previous one, which was there. That was more for binaries, and this one is more for actual code. So if you have code, like what happens with then? So our goal is to analyze source code, as Alex's goal was to analyze binaries, reconstruct the source code, and then try to understand what's going on. But however, uh, what we would be doing differently is we'll be making this more interactive. So how you can analyze the source code interactively, and for that we would be using a tool called as Yorn. So it's a German name. It's a name of a person actually, and that's how the name came for this tool as Yorn. This tool is open source. You can go on yorn.io and you will have a lot of information about what Yorn is. This was built, the base work for the Yorn tool was done in TU Braunschweig, and it was done by, and I think in Göttingen University as well. And I think it was done by Fabian Yamaguchi, and it builds upon his PhD, corpus's work. And we all then became fans of it, and that's how it's reaching you now. Yearn has been enhanced a lot, and that's what we'll be talking about today, using this interactive shell for doing code analysis. So I think I have given these instructions before. If you want to run along with this presentation, it's kind of like a workshop, but I will make it like a half talk and half workshop. So, we build upon some base for it. You can use these instructions. I think they were also pasted on, I think they were also pasted on the comment section, if I'm not mistaken. Yes, I can see them. So you can set these things up, and what we'll be doing is analyzing VLC version 3.0.12. I won't tell you right now why, but this is a very interesting version, and we'll get to know why this is interesting. Also set up Yorn, and you can install it by doing this. Okay, so Yarn is going to analyze big source code and then generate graphs of it, and the graph is going to stay in your machines. It's going to take up a lot of RAM, so you need at least 5 or 7 gigs of RAMs for VLC to at least completely load and get generated. And our analysis should begin. We need lots of CPUs. Just use some modern CPUs. Open JDK 1.8 for Yarn to function. Here are some docs and queries and community if you want to join community. So there's a channel called as Query Corner here, so you can ask questions about queries, etc. if you have some. So something about me. So I'm Suchakra. I'm a staff scientist at ShiftLeft. I did my PhD from Polytechnic Montreal. Yay! So we have Toronto and Ottawa, but Montreal is not represented. It's fine. I did my PhD in computer engineering. I used to work a lot on performance analysis, and now I'm moving on to code analysis. I liked hardware tracing, so I really work deep inside hardwares, and I like samosas and poutine. So, basically I like potatoes because they both have potatoes. Yeah, that's something about me. A part of this talk has also been, of this presentation and talk has also been given in RSA of last year, in RSA Arsenal, and also in NorthSec. So you will find a lot of overlap in those talks. So if you had missed those before, this is a good opportunity to take up. There's also another upcoming conference where a part of this talk will be given. It's Secure Software Summit. You can join that as well. It's on January 27th. You can also try ShiftLeft, the company which I work for, but this tooling is not related to that. It's an open source tool, and you're free to use it. Okay, so what you're going to learn today, you'll gain the ability to find vulnerabilities in large code bases, and that's the key here. We are not going to analyze small binaries or small code bases. Why we need a tool like this is because uh, analysts have some idea of what they want to hunt. So either they grep the whole source code and then try to find patterns between them, or you get a tool which basically allows you to ask questions to the source code. It's very interactive in nature. You can explore multiple areas of source code, and then it gives you answers that, yeah, we got this. So it's going to stop your reliance on using vendor SAST and, always trying to, roll your sleeves and, okay, let me look at the source code. Let me write some grep queries. Here are my weird regex expressions. Let me pull those 30 scripts I wrote. So don't do that. We do it more scientifically, where we have this tool. It has a big graph of the whole code, and now you can ask very precise questions to the graph, and that's what the thing we are going to learn today. You'll be hacker man by the end of the day if you can, if you know what this slide is saying. So why interactive code analysis? As Fabian has taught me, each program is its own universe, and hacking is all about exploring, documenting, and exploiting the rules of this universe. It's like in Matrix, the moment you realize the physics does not apply to you, it's a different physics, you can break all the rules, you can stop bullets and whatnot. So hacking is exactly that. There are different kind of source codes, different kind of binaries. They are all out there. It's its own universe, and we have to find all these ways of exploring and documenting. So when you're writing code, you're always having this in the back of your head. You want to debug it. You would always want to debug it. You cannot rely just on writing it and it works the first time. I mean, yeah, sure, it can work the first time, but if something happens, you would be debugging it. So we are used to this. Okay, let me do this play pause analysis for debugging. With this tool, with interactive code analysis, you are not relying on running it and then playing and pausing it, but we do this kind of thing for static analysis. You run an analysis of the whole source code, and then the source code's graph is ready, you ask questions to it. So that's a way of debugging, but now this is like security debugging. So even before the bug is going to manifest, you are able to ask questions to it. So that's why we do this interactive code analysis. In a short single word, I would say it's like a superpower to auditors. People who are doing code auditing, it gives them huge superpowers, and the superpowers just don't are not just limited to only those auditors at that time. Once you are able to redo this analysis, you are then able to redo it at a large scale. So you can put these tiny rules of analysis you do in your CI, or you can build your own tooling. So if a customer comes in with a similar looking code, you have your scripts and your analysis ready, your deep questions you had asked to the other piece of code, and now you can ask to this piece of code as well. So those kind of superpowers, I just call them that. That's what you get. So like a machine to hunt bugs at a large scale. Okay, so before we understand what Yarn does, we need to have some PL fundamentals, programming languages, and that's what we will do. I think Alex covered a bunch of this already, so I'll be running this through very quickly. If you have any questions, you can put them in the chat or in the comments, and I'm also just going to browse them. But I'll answer them as I'm going along. So what is even code? So we have all seen these nice looking things. Why did we decide to write a statement of code like this? Why is it like this? Those are the questions you might ask. What is even code? So we design them like this so that humans can understand it. But the code is going to run on a machine, so we need this to be converted to machine code, what machine can understand. So there's a whole process that is involved. Whatever you see running, your browsers and whatever is running on your mobile phones everywhere, they're running on binaries. But what humans are going to write is in some very high level language. So you'd have these things, they are called as tokens. So when a computer tries to understand what the human has written here, they will do a step called as lexical analysis, where it will break it down into certain tokens. So it will understand this is an integer, this is an identifier, this is an equal sign, another identifier, etc., etc. Then what happens is that it does some syntactic and semantic analysis, where it converts this tiny tokens and find relationships between them and puts them on like a tree. This tree is called as abstract syntax tree. So when it has to understand what this code means, it can just go through the code, go through the tree easily. So it can say y equals the addition of x and 50. So it will try to like navigate it like this. And the way it would be able to navigate it, it can make more understanding out of it. So after syntactic analysis, we can see that if there's a, this was a single statement. So imagine there was a function, there's a function x, and there's a statement here. I don't know which weird language it is, but it's some language, and it's written like that. So this could actually look like a much more complex case, where you would have a function, and there's a declaration inside the function, and which is y equals x and 50. And this is a much more enhanced. Now we have some information added to it. It understands that these y and x, etc., are identifiers. X is data here, okay, and these are operations which are happening. This is a value, this is like a constant value which is here. So we try to, or not we, but the computer tries to understand it a little bit more better. So our goal is to have this human kind of understanding all the way down to machine, and that's what we do. So let's assume we have like much more complex methods now. So we have a function, there's a if else statement here also. Now we have more complexity added. So instead of just this tree with simple declarations, we have control for graphs. So we know that this function has a declaration, and inside the declaration there's an if statement. It can either return directly to 0, or it can go through this branch. So we have a graph now. It's looking more complex and more comprehensive. Simple ideas which you were seeing like this, that humans can understand, they are now being represented in graph. From this, we also have an extracted version of program dependence. So we know that the value of z would depend on the value of y, which would depend on the value of x. So program is flowing, we have that information, and control is flowing, we have that information, and we have a relationship of all of them together now. So this is a good time where the computer should look at these graphs and start converting them down to something which it can understand. So that's what the computer does. It starts translating it, and it translates it into these tiny intermediate representations, which then get translated to other representations, optimizations, and allocate on register, etc. It can become a bit hairy, and all this is all like complex stuff, but we don't have to worry much about this. We know that there's a simple piece of code, statements that humans understand. They're converted to some sort of graphs that humans can also understand, and machines can also understand a little bit. And then they are converted to machine code, which is going to execute directly on the machine, which humans are not able to understand at all. Then they'll have to use Gitra and go back all the way and go here and then understand it. So a good, middle ground here seems to be like putting things in the graph, which humans would also be able to understand where the control is flowing, how the data is flowing, etc. But this is also something that computer can also understand. It knows that this is a graph, and we also know that this is a graph. So it's kind of like a middle ground, and I'll leave you with this little thought that graphs are important here. So code, again, complex code. This was a very simple piece of code, simple statements, not too difficult. But complex code is like this. It has a lot of these tiny parts, and humans understand them in a different layer altogether. There's package, there are member variables, local variables, method parameters. This is a method block, this is a method return. So we understand this. We understand the relationships between them, that a pi class defines a foo class which calls this function bar. Okay, and then relationships that the pi class inherits from like a recipe class. Okay, and then this bar is defined in this other function, which calls another function, which is defined in another function. So you can see there are these networks of relationships all throughout the code which are here. We can understand that the data is passed from one function to another function, and control is also passed from one function to another function. We have these relationships, and they are all in graphs. So all the code is a graph. So if we are thinking graphs while we are coding, we should think in graphs while we are debugging, and that's what this is about, to give you this graphical representation of code and give you a shell where you can ask questions to what happens to this, and that's what Yarn allows you to do. It's pronounced as Yarn. It's a good way to remember how to pronounce this. Okay, so what is Yarn? So it's a framework for understanding code so that you can gain insights about what your code is doing, and then you build tools for debugging and security. So you have a piece of code, you parse it, you convert it into a graph, you load the graph into a shell, you ask questions to it, and suddenly you start getting insights in 0 days. Looks pretty simple. And so what we'll do is we'll directly jump into how to run through this. So I missed one slide, and this is also about the philosophy, how you're going to use Yarn. So you will query first. An ideal way, you can use it any way you want, but an ideal way is you will ask some questions, you iterate them, you find something interesting, and then you convert them to a recipe or a script that you can rerun them on large code bases, and then you integrate them into your tools, or you can build your own tool with Yarn itself. So code navigation. So let's begin with something super interesting. And what we'll do is we'll load Yarn. Okay. So on the left side, I have Yarn with me. I have already loaded it. So once you install it, you can get the Yarn on your command line. All you'll have to do is just to write Yarn, and Yarn gets loaded. When it gets loaded, it gives you this nice shell. It looks like a bash shell, very inviting. You can ask questions to it. In fact, you can write anything. This is a Scala shell. Super interesting. Look, I can do 1 + 1, and it will say 2. So this is a full-fledged Scala shell. It understands 100% Scala code. So whatever, if you know Scala, you can write Scala, and it will understand it. And that's what we did. We just wrote a simple Scala statement for addition, and it gave a result. So what we have done is we have built a lot of these graph generation and graph querying technology over this nice Scala shell, and that's what you have here as Yarn. So in a real machine, what you would be doing is loading up Yarn, and as I said, you have VLC ready with you. You will be doing import code. Once you do it, it runs for a long time. 10 minutes something, it's going to generate code, because VLC is huge. There's a big code base. Just you can run Linux kernel, it will take like 10-15 minutes still to load the whole graph inside memory. Once you have the graph ready, we have a small data flow tool which gives you some default results, and makes all the nice connections in the graph so that it knows that where the data is flowing from one place to another place. And you run this, and then you can save the graph as well. So what I have done is I've already have this graph. It is ready with me, and I have opened it. You can look at workspace, and you okay, typo. So you do workspace, and you can see that this graph VLC is loaded on the workspace already. This is where the source code was, and it's loaded, so it's true. Okay, so we'll start giving some queries to it. Okay, and the first one that I'll do is I'll just search for a method. So I'll search for all the methods which have a name like parse, and then give me the name of this. So how the queries run is like this. CPG is the graph. So go to the graph, look at all the methods, filter them by a method called as name parse. So at this stage, it is still returning, a method to you, and then give me the name of that method, and give me the list of all those methods. So it's the .l is like a shorthand for listing it. So it will give me the list of all the methods which have a name like parse in them. So if I run this, it's going to run, for some time over the VLC code base, and it's going to give a long list of how many whatever methods which have like parse in the name. So again, I hope the demo gods are happy. Yeah, they are happy. It generated all the methods. So there's so many methods which have parse in their name. Now you would say, like, this is easy, I could do it with a simple grep or over the code base. Yeah, just wait for it. There are interesting things that we would be able to do. So for example, doing things like this. So look at the graph, all the methods which have parse sig in their name, and then generate a map giving their location, which is file name from their location, and then also list all of these methods. So it will go through the code base, and now it gives you, okay, here is the location of this, and here is this complete method. So it can dump the method. So the graph contains the whole method itself, the text of the method itself, but it does not need to only be like text all the time. Okay, so you can save this, you can start browsing this. We have a like tiny browser to browse these methods, so it's like a pager, I guess. Okay, demo gods are not happy here. So so navigating methods further, we can go inside certain methods. So let's look at a method called as parse public key packet, and then look at local variables which are there in it. So go to the graph, find me all the methods which have the name parse public key, find all the local variables inside that name, give me a list of all those local variables and give their names to me. So that's what this query says. And it says, okay, this parse public key packet has a local variable, it's called as iRead. You could go further, you can not just look at that, but you could also look at the type of this variable. And that's the key for Yarn. Okay, it has all this information linked together. So you would be able to look at parse public key, find the local variable, give me the type of the local variable which is there. It says it's size t. So all I'm doing here is just telling you, like, there's a lot of this information. We can find out who called this method. So now we are navigating the graph. We can see that read, MPI, memcopy, these are all the callers of this method. They all called this method at some point of the time. And then the callers. So I just listed the callees, like what's inside this method. But now who is calling this method? So parse public key is basically calling parse public key. We could chain them also. So you could do like caller dot caller dot caller dot caller. Like you could do it like multiple times. So we can see like it's coming from main. So main download key and get update file, they are all calling parse public key, which is then calling parse public key packet. So that's kind of like the call chain that we are able to see here. So again, so you can repeat them. You have things like repeat caller until you exhaust everything. So it's going all the way back. Now you can main call update check val, which call download key, which called update check real, etc. So it's a whole chain. You can see this chain by doing these things. So we are navigating through the graph here. Yeah, I mean, it's all the power is in your hands to navigate the graph. But again, you can work with more complex things. For example, find all the local variables and filter them by their type. So all the local variables where the type is VLC log T. So it's going to list all the variables throughout the VLC code base which have a type called as VLC log T. And it seems that there is like this one local variable which is there. You can find out which method it is used in. Okay, so we can just quickly do the same thing. But now instead of typing the name, what we have done here is to find the method in which this local variable is and then dump the method. And that's what it says. And it goes through this whole code base, and you can see, I think this VLC log T message is where this is. Okay, so and you can do the same things with variables. You can start filtering them, all the local variables where the thing that we just did. So you can do all these filtering, etc. You can look for code complexity. These can be complex. I won't run these queries. They will take some time. So for example, find all the methods where the parameters are more than 4. So understanding things like that. So complexities in code, cyclomatic complexities in code. So for example, find all the methods where there are more than 4 control structures. So now we are getting into a territory which can be interesting from in terms of security. Till now this was like just understanding what's happening inside my code, etc., etc. We are slowly inching towards, okay, this can be interesting. What are the pieces of code which are very complex? They're if else, if else, if else, like nested if else inside. The pieces of code are very complex. Bugs can exist there. So these are the queries which will help you narrow down very quickly in those areas inside the code. Okay, you can run them later on. Find all the complex areas. Find functions which have more than 4 loops, or identify function with nesting depth of control structure which is more than 3. So code complexity, etc. You would be able to understand that. So now calls into libraries. Okay, so one of the big culprits of in C, which is string copy. Okay, so let's look at all the methods in the whole code base which are calling string copy. So we do this by using call. So till now we were doing methods. So method is the definition of the method, and call is where this method is called. So let's look at a call called as string copy, and then find out in which method that call is happening. So all the methods where string copy is being called. So it will go through the whole code base and give you all the methods where string copy is being used. Very standard stuff. Like it's like not at all complex, and also it's going to take a lot of time because there will be many methods where string copy is being used throughout the VLC source code. Okay, so I will probably halt this query because it will take some time and run through the whole graph and find out first all string copies and then find out all the methods where this is being called. So this is a very, so yeah, it ran and it's giving results. So these are all the methods. We can see that, okay, now we are narrowing down. We can browse them and probably understand where string copy is being used. Is it being used safely or not safely? We can try to narrow it down. Otherwise you'll have to look through the whole source code. So still this is very standard. This could be done by grep, but what I'm about to show cannot be done by grep because there is a relation, and this is what it is. So find all the sprintf where the second argument is not a literal. So that's a very targeted query, and now it's entering like serious security domain where you can ask these very targeted questions. So there's in fact like just single place in the whole source code where sprintf is being used, where the second argument is not a literal. And as a code analyst, you would be like, oh wow, we should check it, because imagine if the second argument of sprintf is not a literal. This means somebody else could control it. So eyes start lighting up for an analyst, and then analyst is like, okay, so dump all the methods quickly. So I don't care, I don't want to look at this code line where it is. Just dump the method. And it says, okay, yeah, here it is. And we can see sprintf, the second argument, which is format here. Second is 1012. So the format argument here is not a literal, and it's a red flag. So now you go back and you see that, okay, this format is still defined here, so it's fine. Imagine if this format was coming from attacker control, you would have like a big bug here, because you can use these format string attacks here and basically crash this function. So an interesting find, close but no cigar. We didn't find anything. Okay, so what we'll do is try to look at some like real interesting and close vulnerabilities, like serious ones, which we actually found. And those were found in VLC 0.2, 0.3 VLC 3.0.12. And so VLC Security Bulletin 3.0.13, we informed them and they fixed it. And that's basically what we'll be discussing. So, interesting case again. There can be calls to malloc where the first argument is an addition operator. Okay, you can tell me why it is interesting. Okay, we'll have something like this, and we are trying to allocate x, I think, plus 2. Okay, so if we have something like this, so the allocated memory is now controlled by this variable x. Okay, it's fine if x is like nice, it's fine. Okay, I mean, but if the x is attacker controlled somehow and there is 2 being added to it, so what someone can do is make the value of x such that the moment you add 2, it loops back. You can make this max int 65535, and then it loops back, and this is int y. So it allocates 65535, then plus 2, it loops back. Now you just have 2 bytes with you. Okay, and you wanted to allocate a lot of memory, but now you suddenly have like 2 bytes. So this is a very dangerous situation. And now suppose you're using y and copying content to y, and you're copying a lot of content to y. You have what you call as a buffer overflow attack, or heap based buffer overflow attack. And that's very close to what we actually found inside this. So mallocs having these arithmetic operators, and then these mallocs are being used later on, and that's what this query does. So we define a source. That's how you could do it. Define a source where you find the locations in the graph where there's a call to malloc, and the first argument is a call to an additional operator. You can define this very, very targeted thing inside the source code. And then you define a sink where you say, okay, look at the graph, find all the calls to memcopy, and then the arguments of that memcopy. Okay, so very interesting. So you define a source, you define a sink, and then simply you say sink reachable by flows source.p. So what we'll do is we'll run this query. It could take some time, but this is a query. If you can quickly run this on other source codes, not just like VLC, it's guaranteed you're going to find bugs, because this is very targeted. It gives a clear violation, and we are trying to find sinks which are reachable by the source, and then all the list print all the flows. So .p is like a shorthand for printing all the flows. So it will take some time, and we'll be able to see something out of it. By the time I can explain to you some of the things that it's going to find, and we have a list of this bug that we had defined. Okay, let me increase the size. Okay, yes. So there are parts in malloc where this thing is actually happening, and we created like this yawn query to automatically find this. And there are parts in malloc where parts in VLC where this is actually happening. And what happens is that there is this variable pos, which is attacker control. Why it is attacker control? It is in this file called as update crypto.c, and in line 694 of parse public key function. And what is happening is this is in the automatic updater of VLC. So VLC queries remote DB. It says, okay, it has to update itself, and yeah, it will update itself. And the attacker can control that basically. So after controlling what is being updated, they can control what happens in the pos variable here. And that's where the actual bug starts. So on line 646, the pos points to an attacker control variable. We can choose its first bytes to be 3, such that when packet header len runs, this value becomes 4. And once this value becomes 4, this is being used in another method called as scalar number. And by running this in scalar number, it returns the next 4 bytes, and it stores it in this I packet len thing. Okay, it's very interesting. Like, it simply just runs here via scalar number, and the value of iPacketLen, it stores the 4 bytes. So if we choose these 4 bytes to be FFFF, and attacker can control them coming from pause. So if we choose these bytes to be just FFFF, what's going to happen is that we are using this in later on in malloc. So we have iPacketLen plus 1. So suddenly we have an overflow, which is going to happen here. We have max int, which overflows. The value of whole of this becomes actually 0 or close to 0, depends on like how your compiler is going to run this. And this mem copy is going to crash because you are now trying to copy a lot of content into very less allocated memory. This was not the intention of the user, but you are able to do this. And by running these queries, we were actually able to detect these locations. Wow, okay, still running. Yeah, I mean it runs and then it generates results, but that's what it does. Okay. I guess we cannot do much, but just wait here. So I'll also show you this query database, which is there. So if you're working through large code bases and you have some queries with you, you could also search this big database that we have created for queries. So you could, for example, you want to learn about malloc or like heap queries or something. You can then just start searching and you say malloc, and it says, okay, here is a rule, unchecked read recv malloc, and it says this is what it does. This is how you can check it. It will say this query will match this, which is a bad way of using this malloc, and this query will not match this, which is like it has been checked. So there's like bound checking which has been done here. So there are some other things like malloc mem copy int overflow. There's an overflow here in malloc. There are other kind of queries which are there. So if we also now support Ghidra with this, so there call to string copy happening inside Ghidra. You can inside the binary, you can search that. There are a few Java queries also, so Java is also supported to call to exec, ineffective certificate check, simple constant detection. So things like that. SQL injection, searching for SQL injection in Java code bases, you could run something like this. So give all the methods inside the graph where the method return is of this specific type, and this becomes your source, and the sink becomes query and the parameter and the first parameter of the query, and it's reachable by that. So you would be able to detect SQL injections like this. A parameter is used in an insecure database API call. You can write your own and then submit them to us here as well. It's on github.com yarn.io query database, and all the queries are written in a format and they get added to the database. And once they're added, they are all in yarn now. So once they are added, you can then just get them with yarn scan, which is an automated scanner which can be built in yarn itself. Okay, let's see if it ran. Okay, it's taking a lot of time. So anyhow, you can run this query later on, and what you're going to find is these precise location of this malloc where this rule is being violated. So it begins from this. Okay, nice. It gave me many locations, it seems. So it gave me this malloc location where you can see clearly that an arithmetic operation is happening. And in this location, it is being, let me reduce the size, maybe it becomes a bit easy to see. Yeah, now it looks nice. So similarly, malloc I key size +1. So an arithmetic operation happening in the malloc, and its return value is reaching all the way to memcopy. So all these locations and all these flows that you're seeing are super interesting. You might actually find more bugs in VLC right now if you go and check, We just had time to look at one or two of them, and that's how we found the bug that we had. Must be like somewhere near only parse GSS, allocated buffers, in media code, GNI. Yeah, I mean, all these are like dangerous locations. There might be there might be checks on the allocated length before, or there might be no check. In our case, there was no check, and that's how we found out that there was a bug. But I would recommend everybody to just go and start looking at all of these locations. Okay, so that's basically like kind of like the end of this. We are reaching very close towards the end. You could build custom scanners. So Yarn comes with a scanner. You can run it through the shell itself, not inside the Yarn shell, but you could just do Yarn scan, and you could even just do VLC, and it will give you like results. So here, for example, we ran this. We actually found this with our this automated scan that we ran. So all we had to do was to run Yarn scan path to the VLC source code, and it gave a lot of results. And one of the interesting ones was this dangerous copy operation into heap allocated buffer. It gave the exact location of where it happened, and we started manually then analyzing what's going on at these locations. So trying to narrow down what could be done. uh, Custom scanning, yeah, you could build these custom scanners. Here's how a query looks. So this is a small query that I wrote, which is call to getS. Anywhere getS is used, it's a dangerous function. You write some information, and then all it is doing is finding methods, finding a getS method, find all the methods, find the getS one, and find where all it is being called, and it will just list all those functions where getS is being called. And that's basically a simple one query. You can make complex ones as well, deeper queries, and there are many queries which have been written and like bugs have been found out. I'll give you one example. I'm not going to explain what it does, but I'll give you a real life example of Fort Scout using Yarn. So they recently, not recently, it's been like almost a year now. COVID just skews the time. So Forescout used Yarn, and they detected many vulnerabilities in different locations. So they were actually mostly DNS vulnerabilities in TCP/IP stack, and they ran this. And there are some queries you can see. They also released the queries actually. So you can look at the report. They also have a GitHub repo where like very complex queries are there. I mean, even I have not written like such complex queries before. Yeah, but they're experts, and they were able to write uh, queries that were able to detect like 33 or 34 bugs directly. So I'm just gonna scroll down to some places. Okay, so this, for example, I don't know how to zoom this. Okay, zoom it like this. This, for example, was part of a query that they wrote, and they converted into a script. And all they had to do was just run the script over this large code base, and one by one, one by one, it was giving them direct results with exact line numbers, file name, and which statement they're getting these bugs inside the code base. Yeah, so that's one interesting example of how Yarn has been used in real life. We found 3 bugs in Cisco also, DCNM. I think I have written about that in other places. Cisco DCNM. Okay, yeah. Anyways, you can search it like later. Yeah. So that brings us to the end of the scanners. And if you have any questions, you could join this Discord. I'll give all of these slides to you. You can run this at your own pace. And that's it. Join yarn.io and go through how the code base is. Any questions?
There are questions.
Okay. Yep.
But I'll let it Well, I'll address the elephant in the room because there's been a lot of gibbering on the chat about how's he doing the three screen thing. Sorry, it's off topic, but I got to get that out of the way before we get to the more substantive information.
Okay. Yeah, so these are just windows. Okay. They're just placed properly. I'm using elementary OS, and all I do is double click. It becomes full screen. It becomes small screen. It becomes full screen. It becomes small screen.
Okay, thank you. I appreciate that because that'll get
Yeah.
those people asking off my back. So,
Okay.
very, very interesting. In that we've got a lot of good feedback in terms of this being a really, really cool tool.
Yeah, it's very complex and deep, but there's this little bit of learning curve, just like Ghidra or any other tool. But once you get a knack of it, it's like vulnerabilities after vulnerabilities.
So I'll butt into the line here and ask, how long have you been working with Yarn?
Okay, so I think in 2011 or 13 was the first version that Fabian had written in TU Braunschweig. That group was called as MLSec Research Group. So it's like MLSec Yarn or something. Okay. This is the oldest version. Actually, we found it. So it's funny. This is the oldest version of Yarn which exists. Oh, we have redirected it back to this.
Yes, you must
okay.
upgrade.
Yeah. So So these are I can you can see like pattern-based vulnerability discovery by Fabian, 2015's PhD dissertation. Earlier versions are like version 0.3 or something, some old presentations.
Right.
Okay, like all this is super. This has been there for a long time. It has found a lot of bugs, like 13 kernel bugs, also Linux kernel,
Right.
at that time. And this updated version is people are using it left and right and finding other bugs. So it's a deep static analysis tool. It has been there for quite some time.
You personally have had some deep and meaningful quality time with this tool.
My personal time has been last 3 or 4 years, I would say.
All right. Okay.
Yeah.
So as somebody's approaching this learning curve or cliff, what would you say would be the reasonable amount of time to get reasonably, functionally adept in it?
So I have seen folks with almost zero knowledge of static analysis, understanding everything about compilers and everything, just using this tool, because it's also a very flexible system to understand how code is written. So it teaches you about programming languages itself. Like I learned a lot through this code, through this tool. And I would say I have also tutored other folks in different companies, professional settings, etc. I've seen folks which knew nothing about what static analysis or compilers are and reach a basic level of writing a little bit of complex queries in about 1 month, like decent complex queries which are going to yield bugs.
Right.
Okay, but that's with tutorial, like that's with a tutor. So have you, like, what's your thought on picking it up on your own with some online help?
Yeah, I mean these Force Scout people, they are, I would consider them as experts. They picked it up themselves. We had no connection with them. We just found out Yarn being used in this report out of the blue.
Neat. Okay.
So I believe like they self-taught themselves. So for experts, it's definitely not a difficult case. There are some other folks who are, I would say, intermediate users. They have some knowledge about automated SaaS tools like Coverity and Veracode and things like that, like automated tooling, which just you press a button, it runs some scans, they understand what is a source and sync, some basic understanding. And I have seen them in the industry that they have been able to pick this up in approximately 2 weeks by themselves, tinkering around. And then now they have their queries, and then their queries and their CI systems, and they're finding some bugs.
So how have you cashed in on bug bounties?
No, we are not cashing in on bug bounties at all, giving away bugs for free. So, or maybe other people are using this. Like, I would say we do this occasionally, once or twice, find some bugs, but we are developers of security tools, and not like really hunters. There are people who hunt and then they cash in, I guess. So, like, look at the Forescout thing again. Like, they found 33 bugs by running these few scripts. So I'm assuming other people are also doing the same internally or somewhere
Yeah, but
and caching.
they had to publish or perish. I'm question in the chat was I think
It's a two-part. Yeah.
it's
Are
a
there a set of
two-part.
known queries which are known that
Yeah,
they
it is.
could pick up to use to scan?
Yes, so set of known queries. So as I already mentioned, we have this query database that we have created. It's a big database of lot of queries, and we have added some tags also to each of them. So you can look at these queries, and they run just as it is, just copy paste and run them. That's it.
Yeah.
So these set of queries are there. They will tell you what kind of code they will match and what they won't match. So that's basically it is. Like, there are
Yeah.
hundreds of these queries, and they're all contributed by some people, or we can contribute them, and things like that. So it's, yeah, anybody's, if they want to do it, just submit it to Yoan IO, and they are now in Yoan itself. So the next Yoan version is going to have your query, and
Nice.
your name is also going to be added to this.
I think we dropped a link to the Yarn query database in the chat for both YouTube channels.
Yes, it's queries.yoan.io. If you want to go much more deep and understand how the graph works, there is also cpg.yoan.io, which is like a very deep specification of what the code property graph is.
Hmm.
It will make you understand what are each individual call graphs, etc. You could actually generate, generate call graphs, like visually also, if you are able to do that.
Interesting. Pop that one into the chat too.
Okay, someone added this race condition. I didn't know that. Okay, yeah, that's interesting. So file operation race can happen. So there's this whole query, just copy paste this whole thing and just copy to clipboard and just paste it, and we'll be able to see this kind of race condition that can happen.
Nice. A lot of people just mentioning, reaching out to thank you for both the efforts and that you're doing in the industry and sort of for the talk as well.
Thank you very much. It's always my pleasure.
There's a question there I don't understand.
Okay,
I
let
think
me
that
go
was
through the comments.
just a question about what he was talking about. I think
Right.
that was answered by the link that we posted as well.
Right.
Any other questions, comments from the audience before we wrap up?
Okay, someone was saying I'm using OBS. I'm not using OBS, but yeah.
That would be complex.
Maybe new screen. Okay, that's interesting. I used to use screen some time back. That's not screen.
So then, I guess a related question to the one that Garth was asking you, what would you suggest for somebody trying to pick up this tool by themselves? Like, what resource should they go to first? What should they read?
Okay, so I would say, first of all, go to join.io
Mhm.
and also join the Discord. So sometimes the tooling can be a bit menacing, but the Discord is pretty nice. There are people here who will help you. Look at the documentation and the query database. These two are like important stuff. So we have like this whole doc which gives you overview of what Yearn is, what it supports. There's a nice reference card for queries. What can you do with these queries? The kind of things that I told you, they are all explained here. Control flow steps, complex steps, etc. Like, you can do that. How to work on the interactive shell, launching the shell, how to pipe things, saving things, exporting things, things like that. How the interpreter works, how the workspace works, and things like that. So there are quick start also, which takes you from one simple program, just compile this, just take this source code, start yarn, import the code, start querying. So it takes you from one place, a small challenge, and then you're able to understand the challenge, you're able to do this, and you close the project. So there's a small quick start, and then it starts getting hairy slowly, where you can develop custom plugins completely, and then these plugins get shown here. So I did run.oss data flow in the beginning. You could create your own tooling, and then so it's like run.my custom tool. So you could do things like that. You can develop it, how to develop those with IntelliJ, like we have those kind of things as well. So very, very comprehensive documentation exists for this. It's all completely free and open source. Everybody's willing to join. A quick thing, if you don't want to do a lot of these things and you just trust the queries which are already there, they are not a lot. Again, like the core focus of this tool is to create your custom tooling around this. But there are some queries, as you can see, default queries which are there, and you don't want to muck around a lot. So all you can do is just do yarn scan and the directory of the source code. That's it. And it will give you results, very basic results that, okay, result, dangerous function used, it's here. Okay, so,
Nice.
and then how to write these simple queries and, put them in yarn scan so that you could run these again and again. So these kind of things have also been provided. So I would say go through the docs, go through the query database, and just start writing queries. Import small pieces of code and start writing queries.
Rick asks if there's any plans for
Additional
additional
language
supported
support.
languages.
So yes, so the current support, I can show it to you here, is C++ is there with like this fuzzy parsing. That's what we were using today. So it automatically detected that VLC is C, and it used this C++ fuzzy parser. We are also trying to use Eclipse CDT parser. So, instead of this fuzzy parsing, we'll use more mature Eclipse's parser. Ghidra support is there for x86 64. It's also like medium level support. JVM support, so which means Java will work, Scala will work, and JVM supported languages. It is through this suit decompiler. So all you have to do is give jars, and you would be able to get some results. So this is also like medium level support. It's mature enough. LLVM bitcode, so any language based on LLVM bitcode. So for example, things compiled with Swift or Objective-C. So these are also supported, and JS support is now also added with GraalVM. So a lot of the work that is being done for additional language support, so for example, like this, is being done with an EU project called as Testable. I think I don't exactly remember, which we are doing with different research labs and security groups in EU. So that is all. That's why this all is going to be open sourced. I mean, not going to be. It is open sourced, and it is all publicly available. So yeah, and if you are, working on compilers or any other programming languages, feel free to just join in and start contributing more languages. It's
I think
very easy, actually. If you have a single graphical representation, so the whole thing to do is to convert any language to that graph, then everything else is magical.
I think the question was more around like future state, if there's anything planned or targeted.
PHP is coming in soon. That's what I can tell you, like quite soon.
Wow. PHP.
PHP. I'm just like my gut reaction. But anyway, that's good. That's good. It's good.
Yeah, I mean, lots of vulnerabilities are there. Like people had written off Java, but look, one log4j and everybody's own. So, these technologies are not going to die. I'm pretty sure there are some Fortran servers running somewhere which still have some bugs, and somebody will own them someday. Yeah.
Fair enough.
Legacy
All right.
systems. Awesome. This has been great.
Fabulous. Thank you. I think we've lost Alex by now. He probably had to go and, get other things done. But
shovel his
Any-
driveway.
Any last words from the OWASP Ottawa crew, Garth?
Well, we'll be here in February, so they won't be last. But
Well, closing words.
closing words.
Yeah.
This has been awesome. I've really enjoyed this. This is really two great talks that really dovetailed very well together in terms of code analysis. So I've learned so much in this. So I'm going to have to scurry away and find other sources, because both these tools, I've taken my first step into a larger world. So I think both our presenters, and this has been a great way to kick off 2022. And I would going to suggest that maybe we do this again sometime.
Yeah, I'm definitely looking forward to more collaborations with yourself and also the other Canadian chapters, now that we're all agreeing to continue speaking to each other and continue collaborating. So awesome. And thank you again, Suchakra, for this great talk.
Okay,
It was
thanks, Garth.
lovely to have you
Thanks,
here.
Ophi.
Yeah.
Did I pronounce your name right?
Yeah, don't worry
Okay.
about it. Everyone calls me Ophi. Yeah. There's, the guy who's been providing all of our great music is Scott. So if you were wondering where he got the information, you can reach out to the OWASP Ottawa chapter for that. And for the rest, it's 8:43. So thank you everyone for coming and staying with us. Please sign up for the next one, and we'll see you next month. Bye.
Bye-bye.